Welcome to week 4. So this week we will be studying an F-test for comparing nested models. And in basic terms, what we mean is that we will take a data set and we will compare two models that predict the same response variable. And the idea here is to decide whether one model contributes towards predicting that response variable more than the other model. Okay, and one thing to remember here is that we can't just do this with any model that predict the same response variable. The models have to be nested, and we will study um, uh, what kind of models are nested models. So the first step here is to load the data set, and you will notice that um, in step 1, you're loading the data set that we worked with in module 1 and 2. This is the cars data set, and we're only studying these variables here. So let's run this step. And so here it is. As you can see, this is only printing the three variables that we have picked for this for step 1. There were several other variables that we're not considering this week, but that's okay. We're going to be working with models that predict the fuel economy here using rear axle ratio and weight of the car. So here is step 2, and in step 2, we're comparing the interaction model with no interaction model. Okay, so these are these two models are nested models. So why are they nested? So first of all, let's just make sure we know what they are. So here's the first model. This is the general equation for the multiple regression model that predicts um, the fuel economy. And so here fuel economy is Y, weight of the car is X1, rear axle ratio is X2. Okay. Notice that the first model has the first order term both for weight and rear axle ratio. Those are here. And it also has an interaction term. So this is the first model. And now notice that the second model only has the first order term. It's missing the interaction term, okay? So these are what we would call nested models. Um, one model is nested into the other. Okay, so if you notice that this model here is essentially the predictors here, the terms for the predictors here are a subset of the terms for the predictors here. It's only missing this, right? So this is nested in this. And we can call this model a reduced model. It's reduced because it's missing just one term from this model. And we can call this model a complete model. Okay, so these are nested models. One is reduced, one is complete. And in the homework assignment and also in the project, you have been asked what is a reduced model and what is a complete model. So please make sure to explain it um, in detail. The idea is exactly what I just explained, but it can be slightly harder to see this when you're working with models on your own. So again, nested models are essentially a reduced and a complete model, and you have to explain what a reduced model is and what a complete model is, and I just explained that here. Okay, so now that we know we have these two models, the idea is to decide whether we should use the complete model or if we should use the reduced model to predict the response variable fuel economy. In other words, does this extra term here, does it add any value, or does it contribute towards predicting the response variable? Okay, if it does, then we would like to use the complete model to predict fuel economy. If it does not, then we should keep things simple and just use the reduced model. So that is the test that we're going to do now in this step. Just like any other hypothesis test, this test will also involve a null hypothesis and an alternative hypothesis. And the steps are very much the same as all other hypothesis tests that we have been doing in this class. We define our null hypothesis, the alternative hypothesis, we carry out our test, we get the test statistic and the p-value, we compare the p-value with the level of significance that is given in the problem. And if the p-value is less than the level of significance, we reject the null hypothesis. And if we do reject the null hypothesis, then we have to reach a conclusion. Well, either way, we have to clearly explain what is the implication of rejecting or not rejecting the null hypothesis. So this will be the same. Okay, so if we scroll down, you will see that I have some notes here. We have the null hypothesis for this test is that the beta estimate for the interaction term is 0. So for this test, we have a model that includes an interaction term, and that is the complete model, and then the reduced model does not include that term, right? So the null hypothesis that we will set is for this term beta 3 to be equal to 0, which means if it's 0, then reduced model should be used, right? And the alternative hypothesis is that the beta estimate for interaction term is non-zero. So if it's non-zero, then if we reach the conclusion that we reject the null hypothesis so that beta 3 is non-zero, well then we have to conclude that this interaction term in the complete model contributes towards predicting the response variable. So therefore we should use the complete model. Okay, so we will do this test, we'll get our p-value, compare it to the level of significance, and reach the conclusion whether we should use this model or this model. Okay, and the ANOVA function in R will be run to carry out this test. So let's run this. So the first step is to take the complete model and create it in R. Okay, so here we have fuel economy, weight, that's the first order term for weight, rear axle ratio, first order term, and here's the interaction. So this is the complete model. That's why we're saving it in a variable called fit underscore complete. Okay. And then the second model, which is the reduced model, and it's pretty much the same, except you'll notice that here we don't have the interaction term. And this is the reduced model. And once we have the two models set up, this is the ANOVA test that we will run. So this is the ANOVA function in R. It takes two inputs here. We're giving it the complete model and the reduced model, and let's see what the output, what is the output that we get. So let's run this step. So here's the output, and the relevant cells here to look at are these the f value that's given here. This is the f value, and then this is the p value, the probability value, 0.0274. So clearly less than, say, 5% level of significance. So we can reject the null hypothesis. The null hypothesis was that the coefficient for the beta 3 coefficient for the interaction term is equal to 0. So that was our null hypothesis, and we reject it. So that means it's non-zero, and therefore we will say that we have statistical evidence that the interaction term does contribute towards predicting the response variable here, fuel economy. Therefore, we should use the complete model. And the hypothesis test is explained here. Okay, so my only one important reminder is to please make sure that you use the equation editor to write the null and the alternative hypotheses, and then also explain in words what it means. Okay, so this is the explanation in words. And then here's the rest of the test. So as you can see, we got our p-value 0.0274, and we rejected the null hypothesis. Okay, so it's pretty simple actually. It's not the only tricky thing with this topic is to figure what is the complete and what is the reduced model. And you can't just test any model here. Okay, so I can't just take three other new variables that are not in this model and add them here and then test those. Um, it makes a lot of sense to test the models that are nested. Okay, and so usually we will do tests for a few terms um, that are added to one of the reduced models. Okay, so let's go to the next step. So here now we're working with with the economic data set. This is the data set we used in module 3. And we're working with wage growth, unemployment, and GDP. So let's just run this first. So here's the data set. I'm only displaying the first 6 rows. So now let's go to step 4 and look at this model. So in step 4, we have a complete second order model with comparing a complete second order model with interaction model. So now here's the model. Y is wage growth, X1 is unemployment, X2 is GDP growth. And so here are the two models that we want to compare. So first, let's look at this model. This is now the reduced model. It includes the interaction term, okay, and the first order terms for X1 and X2. Why is this model reduced? It's reduced because notice that all these terms here are included in the other model. Okay, so it's nested in the other model. And the complete model actually includes two additional terms. Those are the squared terms, those are the quadratic terms. So now this is the complete model and this is the reduced model. Okay, again, this is reduced because all of these terms here are a subset of the terms that are included in the complete model. That's why this is reduced. And then obviously the complete model includes additional terms that are going to be tested. So the question now is, what would be the null hypothesis? Well, because now we're testing for these additional terms here, the idea really is to test whether this first order interaction model should be used to predict the wage growth, or do we need the quadratic terms? So do we need a quadratic model to predict wage growth? So the null hypothesis would be that beta 4 equals beta 5 equals 0. Okay, so the null hypothesis is that we don't need these terms so that the reduced model is sufficient. And then the alternative is that they're non-zero, and well, at least one of them is non-zero. So then the conclusion will be that we actually do need a quadratic term to, or at least one of the quadratic terms contributes towards predicting the wage growth. So that would be that. And then again, we will set the complete model and the reduced models in a similar way. So by now um, you should know exactly how writing the equations work in R. So the LM function, just write out your equations for the complete model and the reduced model. And again, we take the complete and the reduce and we input it to the ANOVA function. And let's run this. And we get our F value and the P value. So notice that the P value is almost 0. And so this hypothesis test is telling us that the P value, because it's 0 and it's less than level of significance of 5%, so we can reject the null hypothesis and conclude that one of those two quadratic terms, they do add value in predicting the wage growth. Okay, so the hypothesis test will be the same as the one that we carried out here. So the right here in step 2. So the steps will be the same, except here the null hypothesis is for the two additional terms, the quadratic terms that were added. Okay, and then pretty much the test is the same as before. So this should be a fairly straightforward concept. The textbook also includes an example, so please make sure you go over that as well. And this one of these questions is also included in the project. So I'm hoping that this lecture will help you do that question.